IoT, or the Internet of Things, is a domain that is getting a lot of traction in India. The government of India is spending big funds to boost the electronics manufacturing industry in India. And in today's episode of the Zista podcast, we're going to go deeper into this subject and get some answers for you. Welcome to the Zista podcast, where we invite industry leaders and academicians to answer questions that students have within a specific subject area. Joining me today is Ashish Chintal. Ashish has over 20 years of experience in the business and technology domain. He's a Stanford lead alumnus. He holds an MBA from NMIMS and he's completed his BE in electronics and telecommunications from Mumbai University. In the course of his career, Ashish has played diverse roles, everything from business development, partnerships, product management, program management, and operations. Currently, Ashish heads strategy and business operations for Napino Digital Solutions. He has worked with leading brands like Lenovo, Vodafone, Airtel, Mobilium, and Ernst & Young. Welcome to the show, Ashish. Thank you for making time in your day and coming here to talk to us.
Thank you, Amit, and thank you, Zista Podcast, for inviting me. I'm glad to be interacting with the students community and put across the message on what's happening in the electronics and the IoT industry, and more specifically in the manufacturing space. So glad to share my experiences and my perspective. Let's just dive in.
Absolutely. So why don't we start with a very basic question? I think it'll really set the tone for our discussion. What is IoT and how does it work?
Awesome. So IoT by definition is Internet of Things, which essentially means that you take a dumb device or an appliance which traditionally used to work by itself. You had a switch on, switch off, or a remote button. Right now, what we are doing is we are adding a layer of connectivity onto it. And the connectivity, there are multiple options. There is Bluetooth, there is Wi-Fi. And what we already know is through our mobile phone, 2G, 3G, 4G. So you can add any of those connectivities and then send some data from that device as to what is happening. For example, the water is now heated. If we consider an example of a small water heater, it will then push that data onto the cloud, and then cloud is not really a cloud, but it is a set of servers deployed across, for example, AWS or which is Amazon Web Services, or Azure, Microsoft Azure, or there is GCP by Google. So there are a bunch of cloud providers who essentially collect data from these IoT devices, and there is algorithm or logic placed into those mechanisms, which is nothing but a platform. In that intelligence, it will then push back some commands back to that device to say, hey, now you switch the device off. Or you can also come up with a programming that, taking the same example of smart water heater, switch on the water heater at 9 a.m. every day and switch off at 9:10. Or when I'm coming from office, then switch it on at 6:30 p.m. and switch it off at 6:40. Now, this kind of access or feature were not available earlier. So this is what smart devices are being converted into with the help of IoT. And there are a bunch of examples, and we can dive into some of those for better clarity. But to summarize for the audience, it is nothing but you're adding a level of intelligence to sense something. So there are sensors. Then you're communicating that information over a connectivity layer, and there is an intelligence sitting somewhere on the platform which can direct it to act in a particular way. So that's in a simple way what IoT is.
It's really good, the description you gave. And I remember for a long time I was working in telecom, and we had the situation where we realized we're going to run out of IP addresses. So we shifted from IPv4 to IPv6. Which basically supports more digits in the IP address. And one of the main reasons why this shift happened, is because there was a clear anticipation that there would be millions, perhaps billions of devices which will be connected to the internet. So it's really fascinating, and I think that there are so many different careers that students can actually explore in different parts of the spectrum. So before we get there, I wanted to ask you, Ashish, what attracted you to join, the electronics manufacturing industry and, have a play in IoT?
Yeah. So if you look at my career, I started with telecom again. So I spent a lot of time in the technology operations at Vodafone. Erstwhile, it used to be Hutch. It used to be Orange, which later became Hutch, and then Vodafone. I was part of that journey, and then I pursued an MBA program, leaving my job. Then I worked in consulting for Ernst& Young, and then I did product management for a US based company. So I had exposure of telecom industry, then I had exposure of IT industry. And then I again went back into telecom, but this time it was on the business side of things. Earlier it was all technology, but now I was working as a business lead, uh, pan India for Airtel. And then when I had the spectrum of IT, electronics, the piece that was missing was the hardware side of things. So that's what attracted me to join this area, which is IoT, which had in IoT, it is everything. So there is an IT intelligence, there is a connectivity, which is telecom, then there is a hardware. So it's putting across all together and bringing it into play. So that kind of attracted me because that would cover the whole area. Because these days, it is not just IT or a mobile application. Everything is moving towards, say, smart speaker. We have Alexa or a Google device in our home. So all the intelligence is coming into one device, which is an IoT device. And when you look at telecom, the number of SIM cards that can be sold is related to number of people who are there on the planet. But if you look at an IoT device, every home can easily, today it would be easily about 10 to 12 devices, IoT devices each home have. And now that is going to drastically change, right? From doing plantation work if you need to do in your home, or control the water flow, or as I took the example of smart water heater. So all applications will come with IoT connectivity, and that's where the explosion of connectivity will increase and the IoT will flourish. So that was kind of an area that this is an exciting area for me, and that's why I pursued this option.
Awesome. So it was really exciting for you. That's pretty clear. You're speaking with a lot of passion, and it just shows. And that's really really nice. Now, I see, India today is a major player in global electronics manufacturing, and it's rapidly becoming a manufacturing hub, I would say, for electronic devices. The
Yeah.
sector is actually going to cross 300 billion US dollars by 2026. That's the long-term projection. And the government of India is really pushing the domestic electronic manufacturing scene. So, from your perspective, what impact will this have on our economy? And how can engineering students benefit from this wave?
Oh, amazing question. So I was just taking some reports recently. So the whole world today is dependent largely on China when it comes to
Right.
electronics devices procurement. And even as India, uh, we have a trade deficit of about $100 billion annually. For the first time, we've surpassed that. And in fact, that increased after COVID. And we procure about $30 billion of electronics from China.
Right.
First of all, there is a huge trade gap with China, and more so specifically, electronics is what contributes to the most of that. Now, what the this gap does is, because there is a trade gap, trade deficit, what we are essentially doing is the whole consumption that can happen by local industries within India are now dependent on someone who's manufacturing in China. So
Right.
first of all, there is a political risk if someone can cut the cord one fine day for whatever reason. So that's a risk. And imagine if we are deprived with mobile phones, or if you want to purchase a mobile phone which has gone faulty, and for whatever reasons they tell you that it will take 3 months to deliver or 6 months to deliver. We can't live with that, right? So that's why it is important that we are not over dependent on a particular country or an import kind of a scenario, which means we need to create local industries. So what this also does is, because of the trade deficit, we are essentially helping another country or another manufacturing hub in another country prosper, because we are giving them money. We are
Oh, sure. We're the customers in this context. Yes.
and what this is also doing is the local industries are now not able to compete with them. So it's a spiraling effect, because if we put that money here and let the local companies grow, they will grow and they will then be in a position to compete with them, which is today not happening. So somehow we need to have policies, which government of India is now doing, is helping with a lot of incentives, I would say, a lot of better subsidies, plus the duty structure, import duty structure, so that we promote local industries. So what has not been happening over last, I would say, 10, 15, 20 years, that we are trying to change now. It's going to be a difficult task. It would not happen overnight, but that is a process which is happening. That's one. Second, there are some countries, because of the political reasons, many of those countries don't want to deal with China, for example.
Right.
They are looking at an alternative where they can get their manufacturing done, because everyone wants to protect their interest on don't want to put their all eggs into one basket. So they need to have an alternative. And they're also doing it by setting up local manufacturing facilities in India. They're also having a lot of, sanctions or duty structure. Let me give you an example. I was working on a product recently. Now, this product was getting manufactured in China, for example, at $100.
Okay.
Now, but when it gets sold to country X, I will not name that, then they have a sanction there, which means that $100 product will have to be purchased at $125.
Sure.
There is a 25% sanction. Now, while in India, because of whatever infrastructure reasons, if you are able to manufacture the same product at, say, $110, we are still competitive. So a lot of factors, not only the government in India is supporting, but a lot of international markets, a lot of companies and governments are looking at India as an option. So this is the time to capitalize on this and grow our industry.
This is really good. Everything that you said actually makes a lot of sense. We want to increase our self-reliance. We want to reduce the trade deficit. We're obviously leaning a lot on our forex reserves, to finance that trade deficit. And I think there's clearly an opportunity here for industries to look at India as a viable alternative. So it's not just industries in India, but you could say other countries that could actually rely on India to look at India as a manufacturing hub. And I think that's really good, right?
And the best part I would add here is we have a humongous population here. That means local consumption is much higher, which means I talk to a lot of my customers. They would launch their product in US or Canada or UK, but for them, success is when it works in India, because if it can work in India, then it can work across. Because if you can make it successful in India, immediately they get huge volumes. That's clearly an advantage of population that we have, and growing population in the younger bracket, who's earning, who's willing to spend. So there is huge potential to come up with innovative products, to launch innovative products, and we will find market here in India itself. We don't need to depend a lot. That's an icing on the cake, but we have our own market here in India to serve.
A strong domestic economy is what you're saying.
Absolutely.
Is more than enough to help this industry take off. And as it takes off, what we're going to see is basically a lot of jobs getting created, a lot of qualified engineers required in different facets of those operations. And I think for students, this is really good news. So there are students who are looking to study in India. There are students who are looking to study abroad. But the fact remains that India is a market which is growing. The domestic market is really blossoming. And the recent push that we've seen, the entire structured way in which the government of India is promoting the electronics manufacturing industry is really heartening to see. Okay, so I'm really happy that we had this discussion. I remember, sometime back you had posted an article on LinkedIn, and you're someone who's worked in IT and telecom, and you were trying to kind of talk about why a career in IoT or electronics manufacturing is actually can be as interesting, if not more, than IT or telecom. So, could you maybe jog your memory, go back to that article, and tell us a few points that you made?
Yeah, so if I recall that correctly, the first point that I said was here you're building a physical product. So you can actually touch and feel that product, and not like a software where you create some application and then that gets hosted, someone downloads it. You're not there to see how the usage happens.
Right.
But in this case, you have something to hold, look, feel, see the transformation. That's the second point which I mentioned, that you have to see the transformation and the kick you will get to be part of this transformation. First, to build a prototype. First, to design the PCB. That's what we study traditionally in our engineering colleges, and not many would be working in this space, and that is what we should change. We are traditionally a superpower in software, but not so on hardware. But mind you, in hardware again, we do very good work in designing, but manufacturing of a product is an area of improvement to us. So coming back, so the whole journey of first coming up with a prototype, then doing an engineering validation build, that's the second stage. So you do another iteration, then you do a design validation. That's the third step that you build. You build another product once again. Then you build a fourth iteration, which is a production validation test, to say that, hey, can this product be manufactured at scale? And then you start churning out units in thousands. And when you experience the whole process, this is not a one-to-one job. It takes sometimes 9 months to a year to 12 months for the whole journey to culminate. And then once you see this your design product getting manufactured, tens or 20,000s of those every month, and it gets flourished across the market and people are using it every day. That's the kick that you will not get in a software industry, I would say. The third part is largely what we covered earlier, is the nationalistic factor, right? Where we want to reduce our dependence on external country. We want to be self-sufficient, and this is the right time because industry is flourishing. There are a lot of opportunities, and this cuts across industry. It is not just electronics is applicable in defense industry. It is there in consumer electronics. It is there in logistics. You name it, medical electronics. You name it, everywhere you will find electronics. So coming up with innovative products, designing, manufacturing, there are a whole area, right from on the business side to the product design side, to the mechanical engineering side, to the packaging, shipment, logistics, customs. There is a whole piece involved in terms of job creation that this industry can do.
That is really good news. And, I sense really good times ahead for the industry. Now, obviously, the industry wants to attract qualified people. So that brings us to the next question, what kind of qualifications or what kind of educational backgrounds do students need if they're looking to become, say, an IoT engineer or a developer?
Okay. So let me cover this in two buckets. One is the design piece, and the second is the manufacturing piece. The design piece is largely similar to, I would say, software industry because we need that similar kind of talent. Here we need people who understand electronics, and for all the reasons, basic electronics is a subject in the first year or second year of engineering. So all engineers would typically have some exposure to electronics. Then there are microcontrollers or ICs involved. You need an ability to program that. So that's an embedded engineering kind of a skill set that is required. Then there are skill sets such as designing a PCB, understanding about which component should go into the circuitry. So skill set around electronics, skill set around programming, I would say is a very good factor for selection on the design side. And it's not just electronic design because, as I said earlier, it is IoT is something which is bringing everything together. There's a hardware, software, cloud integration, everything together. So we also need software engineers. We also need cloud engineers. So that's, I would say, a design area kind of skill set. Purely, I would say, diploma engineers or postgraduate engineers or graduate engineers in the field of electronics, mechanical, computer definitely will make sense, even telecom. Second area is on the
Manufacturing.
manufacturing side.
Right.
So here we have manufacturing plant heads who are basically managers who spend 15, 20 years, who've grown from uh, even soldering a component or carrying out assembly activities of a product. So there are ITI engineers, ITI kind of stream is there. After 10th, there is some kind of a vocational training that is taken up. So what are the people whom we employ for carrying out assembly work, soldering work, who work in the area of building a mass scale units. Then we have supply chain engineers who are working with various suppliers to procure a particular component, who also have skill set of negotiation, managing the inventory, warehousing. Then the third bucket would be SMT engineers. So the whole process of mounting of components onto the PCB is called as an SMT process, surface mounting technology. So there are some specialized engineers who are capable of handling such kind of an activity, because every electronic device would need to undergo this kind of an SMT process.
Sure.
So the special engineers who can perform that activity. Then custom duty, packaging, handling, all those are some other segment when it comes to mass scale manufacturing. So those are the buckets I would put: a design area, which is purely engineering driven, and on the manufacturing side, which is a multi-dimensional skill set around manufacturing and supply chain management and customs. And also a layer which I would put as a business layer, which is aspects related to sales, related to marketing, market research, business development, partnership, alliances, strategy, uh, uh, and these kind of, they cut across. Now, this is the layer when it is very easy for other industry to come and play a role, who do not have a strong, I would say, an embedded experience. So that's an entry point for someone who's very interested, has got a lot of experience already in other industries, but want to enter into manufacturing. That's a space. But someone uh, who is new, who is a student right now and wanting to choose a path, I would put them across in these two buckets, one on the design side and one on the manufacturing side.
So I like the way you kind of really fleshed this out in a lot of detail, and while the industry is growing, it really needs qualified people. What you've done is you've systematically broken it down into two buckets, having that extra support layer, which is the business functions of sales, marketing, strategy, business development. But you've done a really good job in detailing what you would need on the design side, what you would need on the manufacturing side. So I'd like to say a big thank you. And I think to the listeners and viewers who are tuning into this show, I'm sure they'll really appreciate a very deep dive that you've done, talking about how the industry needs people and the kind of skill sets and the kind of backgrounds that, would be required. So that's really nice.
Awesome. And one message that I would like to give to someone who's
Sure.
aspiring or is on the verge of selecting an industry, is to get your industry right, to get the area of work right, because don't go after salary or the perks that you might get in some of the large companies. But if you want to create an impact, if you want to enjoy what you're doing and continue to do that in 15, 20, 25 years of your career, then it is important to choose the right industry and the right role. Don't go after salary. That's my message to young people, because salary will always pick up. In 4-5 years, you will always be on an average or higher. But if you're liking what you're doing, you'll enjoy your work. So that's the message that I want to give to students who are on verge of selecting a career.
Awesome. That's an excellent note to wrap the show. And thank you so much for making time to come here, Ashish. We've really enjoyed hosting you, and we look forward to hosting you again, where we're going to kind of discuss a little bit more about IoT and electronics manufacturing. So thanks for that.
Awesome. Thank you, Amit, for having me here. I really enjoyed.
I hope you enjoyed today's session. I'm happy to say that we're going to be welcoming Ashish once again back to the Zista podcast to continue the conversation on IoT and electronics manufacturing. If you like what you've been listening to, we'd encourage you to subscribe to our YouTube channel. And yes, you can most certainly catch the audio version of the podcast on Apple Podcast, Google Podcast, and Spotify. Our handle is the Zista Podcast. Till we meet again, we'd say, stay curious.